Okay. Good morning, students. Screen is visible. Screen is visible. Anyone? Can you please give me the reply? Anyone, please give me.
Yes, sir.
Okay. Okay. So today we are going to discuss lecture number 42, methods of starting synchronous motor. Methods of starting synchronous motor. So you know that the synchronous motor is not self-starting, okay, which is not a self-starting motor. It is necessary to rotate the rotor at a speed very nearer to synchronous speed. Okay, so generally the synchronous motor will be a constant motor. Okay, it is a constant speed machine. It is constant speed machine, ns, synchronous speed. Okay, it is running at synchronous speed, ns. So we know that ns is equal to 120 fs by p. 120 fs by p. Okay, now if the number of poles, okay, if number of poles will change, if number of poles will be changed, then what happened to my synchronous speed? Synchronous speed is also be gets changes. Okay, gets changes based upon the supply frequency. Okay, 50 hertz, this also be changes. But anyway, we have to make, or we have to run the machine only at run the machine only at synchronous speed, only at ns. Okay, run the machine only at ns. That is our synchronous motor. Okay, synchronous means the unity. Okay, synchronous speed. Now what we have to do? Okay, so to make the motor to run at synchronous speed, either you have to keep the number of poles and the frequency should be the same. Number of poles should be 4, the frequency should be 50 hertz. Okay, so we have to take these two parameters in the consideration. Okay, generally as per the concept, synchronous motor is not self-starting. That is the agenda. Okay, now to make the motor to self-start, okay, to make the motor to self-start, there are 4 different methods to start this, to make the motor to starting. Okay, so there are 4 methods are there. Okay, these are the 4 methods are there. The first method will be a pony motor. Okay, pony motor. Second method will be a damper winding. Third method will be a slip ring induction motor. Fourth method will be a small DC machine coupled to it. Okay, so to make the motor to self start, there are 4 methods are available. Okay, there are 4 methods are available. So one method will be pony motor, second method will be damper winding, third method will be slip ring induction motor, fourth one is small DC machine coupled to it. Now we will see step by step. Okay, first method. First method, it is pony motor. Pony motor means, the concept of pony motor, it is very simple. Okay, pony motor means it will be called it as, it will be called it as a small external device. Okay, it will be a small external device like like induction motor, small induction motor. We have to connect it. That is known as pony motor. How the experimental arrangement will be taken place means, experimental arrangement, it will be look like this. This is the motor. Okay, this is the synchronous motor. Okay, this is synchronous motor. Here only you are giving the 3-phase supply, 3-phase supply to this motor. So this motor will be connected to the bed by using the bolt and nut. Here connecting it. Now this is the shaft. Okay, this is a shaft. This is a shaft. Now, external device means I have to take a small motor. Okay, a small motor. This is nothing but induction motor. So through induction motor I can give coupling. Okay, I have to connect the shaft of the induction motor to shaft of the synchronous motor here. I have to connect it. Okay, the same motor will be connected in another bit also. Okay, so this type of arrangement is known as Pony motors. Okay, so in this arrangement the rotor can be brought. Okay, in this arrangement the rotor is brought to synchronous speed with the help of some external device. For example, a synchronous motor is not at all running at 1500 rpm, since it will be a constant speed, but it is running at 1590 rpm. So how much deviation will be there? My synchronous speed will be 1500, but it is running at 1490. Okay, so almost 10%. Okay, there will be a 10 rpm difference will be available. We know ns is equal to 1500, but the motor running at 1490, so almost a 10 rpm difference will be there. Now you have to make the motor to run at ns 1500, so there will be a 10 rpm difference will be there. To make the motor to run at 1500, from 1490 to 1500, you need some device to connect with your synchronous motor. That concept is known as Pony motors. Are you understand my point? Are you understand my point? Normally your synchronous motor should run at 1500 rpm. Okay, it should be run at 1500 rpm. Okay, unfortunately it is running at only 1490 rpm. Okay, now you have to make that rotor speed 1490 to 1500 rpm. We have to make it. So how to make? You need a small device to connect with your existing arrangement. That small device which used to make your rotor speed to run equal to the synchronous speed, that is known as Pony motors. Okay, so when the rotor attains synchronous speed, once you connect the Pony motors, then the rotor attains the synchronous speed. Then we have to give DC excitation to field winding. Okay, so after some time, okay, after some time, maybe a 1 second or 2 seconds, then the machine will be running at a constant speed. Constant speed means it is running at 1500 rpm. That is known as synchronism. Okay, that is known as synchronism. Understand or not? Synchronism meaning means, the meaning of synchronism, the motor makes to run synchronous speed ns. Okay, that is known as synchronism. Okay, that is known as synchronism. Okay, once synchronism is developed, then we have to, Pony motor should be removed. Okay, we have to remove this Pony motor. Understood or not? Or understand my point? Or understand my mind? Pony motor is a concept which is used to connect with your synchronous motor to make the motor to run at synchronous speed. Okay, once the motor starts running at synchronous speed, immediately we have to remove or decoupling the Pony motors from your synchronous motor. You have to remove it from the concept. That is my first method. Okay, that is my first method. Any doubts in this method? Any doubts? Students, you have any doubts in this method?
No, sir.
Okay. Second method, method 2. Method 2 will be damper winding. Okay, damper winding. What does mean be a damper winding? You see this arrangement. This is some circle they have given. Okay, they have given. Okay, this is a field winding. Inside, you see here, this is a field. This is a rotor. Field winding. Okay, rotor field winding. And this one will be a damper winding. Damper winding means, okay, in damper winding means, I will explain. It will be connected in additional winding connected in stator. Additional winding connected in stator. Where it is connected means it is connected in armature. Okay, armature. In armature, there will be a stator windings are there. In addition to that, we have to connect this winding. Okay, this winding will be normally in stator. Normally the windings are there. Okay, the windings are there. This is a winding. Now in the there will be additional windings we have to connect it. Okay, this is nothing but additional winding. This additional winding is known as damper winding. Damper winding. Understand? Okay, so this additional winding which make the motor to self start. Okay, to self start it. And also this type of damper winding arrangement, it is only applicable to screw cage rotor. Okay, screw cage rotor. It is only applicable to screw cage rotor. Okay, in screw cage rotor, what is the concept of screw cage rotor? The rotor bars, the rotor bars are short circuited with Hendrix. Hendrix. Because you know the structure of what is the structure of a screw cage rotor? Okay, this is the rotor structure. Okay, this is nothing but bars. Okay, this point will be the Hendrix. Okay, this only will be shorter. Okay, that's what I have written. Rotor bars are short circuited with Hendrix. The concept is very simple. Okay, here in damper winding we are giving the three-phase supply. We are giving three-phase AC supply. Once we give three-phase AC supply to the stator, then the motor starts rotating as an induction motor at subsynchronous speed. Okay, the motor starts rotating as an induction motor at subsynchronous speed. Then we have to give DC supply to field winding. Okay, to the field winding. At a particular instant, that is after 2 seconds or 3 seconds, the motor gets pulled into synchronism and starts running at synchronous speed. Okay, so as the rotor rotates at synchronous speed, then the relative motion between the damper winding arrangement, then a rotating magnetic field is zero. Hence, the motor is running as synchronous speed. There cannot be any induced EMF in the damper winding. Okay, there is no induced EMF in the damper winding. Why? Because we are connecting this damper winding means this damper winding will be active only at starting position. Okay, only at starting position only this damper winding will be activated. Okay, so to run the motor as induction motor to start. Okay, so once the motor will be starts running at synchronous speed, then this damper winding will be deactivated. Okay, the damper winding will be deactivated. Are you understand? Okay, or understand how to deactivate means this damper winding will be short circuited. Okay, so the motor gets started as induction motor. So in damper winding, the current value will be very high. The current is very high at starting position. Okay, at starting position the current value will be very high. Okay, so to limit this starting current, we are using a star delta starter or auto transformer starter or stator resistance starter or direct online starter. Or understand this concept? Okay, or understand this concept? Again I will explain. The damper winding means which is the additional winding which will be connected in the stator armature winding arrangement. Okay, stator armature winding arrangement. And this damper winding arrangement, it is only applicable to screw cage rotor. Why it is applicable to screw cage rotor? The rotor bars are short circuited. Here also the damper windings are short circuited with end rings. The damper windings are short circuited with end rings. Okay, now the operation, we are going to give a three-phase supply to this stator because the damper winding will be a stator arrangement. Okay, this is nothing but stator. Okay, we are giving three-phase AC supply. This is a AC supply to this stator damper winding arrangement. Okay, once you give the AC supply, then the motor starts rotating. Okay, then the motor will starts rotating has an induction motor at subsynchronous speed ns value which will be lesser than 1500, which will be running at 1490 rpm, which is running at 1490 rpm. Then we have to give dc supply to field winding. Okay, so once you give the dc supply to this field winding, after a particular instant the motor gets pulled. Okay, the motor gets pulled or make the motor to run at synchronous speed ns 1500 rpm. Okay, then the machine will starts rotating at synchronous speed. Okay, so as the rotor rotates at synchronous speed continuously, there will be a relative motion between a damper winding and rotating magnetic field. What is the relative motion between damper winding and rotating magnetic field? Which will be zero. Which will be zero. So therefore the motor is running as synchronous motor. Okay, so there could not be any induced EMF in damper winding arrangement. Okay, and also please note down the point, this damper winding is only applicable for starting purpose. Okay, when you start the motor, then only this damper winding will be active. Okay, so once a motor will be starts running at synchronous speed, automatically this damper winding will be deactivated. Okay, so another drawback is here, the damper winding, by using the damper winding the current value, the starting current will be very high. Okay, the starting current will be very high. To limit the current value, okay, to limit this current starting current only, we are using the DOL starter, direct online starter, or auto transformer starter. Okay, or auto transformer starter, or we can use star delta starter. Okay, star delta starter. Any doubts? Okay, so the theory which is available here. Okay, I have given you points step by step. Okay, so please go through these points. Go through these points. Third method. Third method will be slip ring induction motor. You know, slip ring induction motor is other name called it as, it will be a, what is the other name called? The other name called it as, it will be a wound rotor induction motor. Wound rotor. Wound rotor induction motor. Okay, now this is my machine. You see here, this is a machine. This is stator. Okay, this is stator arrangement. Three-phase supply. This all this both stator and rotor will be call it as, all call it as synchronous motor only. Don't think it is a induction motor. It is a synchronous motor, but they are using rotor in synchronous motor. They are using the slip ring induction motor. Okay, instead of scroll cage, they are using the slip ring induction. motor. Okay, now this is stator, this is the armature, this is the armature, it is a neutral point, three phase supply. In armature they are giving the three phase supply. Okay, now this is a shaft. Okay, this line will be a shaft, and you see this is a rotor. Rotor means, you know, it's a field winding. Rotor means field winding, but here they are taking a three phase winding, that is nothing but field winding only, but they are taking screw cage rotor. So you know the operation of screw cage, slip ring rotor. In slip ring rotor, the slip rings are short circuited with brushes. In slip ring rotor, the slip rings are short circuited. So the derivative at the end of the interval is given by d del divided by with omega I plus 1, because this one is given with the brushes. You see here, this is slip ring, this is the brushes. Okay, this is the brushes. But understand, this is a slip ring. Okay, so the rotor, all the three phases will be connected to slip rings. Okay, this slip ring is mounted on the shaft. Now the end ring of the brushes and slip ring will be connected with the triple pole double through switch. TPDT stands for triple pole double through switch. Through switch. Okay, so because anyway in field winding we have to give DC excitation. Okay, DC excitation. So through my switch I'm giving the DC supply. Okay, I'm giving the DC supply. You see here, I'm giving the DC supply here, plus minus. Okay, the DC supply, when the switch is on, it is only for starting purpose, then it will be closed, then it will be go for running purpose. Okay, that is a concept, starting and running. Okay, when the switch will be closed, that is starting, when the switch is open, that is running. Okay, now this all this slip rings will be connected with the another end of the switch will be connected with the three resistance. Will be having here, this is series resistance, or series resistance is other name called as a rheostat. Three rheostats will be connected in series. Be connected in series for variable purpose. For variation. Okay, the concept is very simple here. When the stator is excited, then the motor start as a slip ring induction motor. Okay, now by using this resistance, the starting torque is will be very high. Okay, now what we have to do? We have to reduce this resistance value. Okay, based upon the moment of this resistance, we can adjust the synchronous speed to NS 1500 RPM. Okay, 1500 RPM. Here also, these windings are shorter. Okay, these windings are shorter. Okay, the another concept here, we are providing when the motor attain the speed near a synchronous speed, then we have to give DC excitation, because at the starting stage only, when the motor is starting stage only, we are operating with starting resistance. Okay, so once the motor will be starts running slowly, then we have to adjust this resistance, then you have to close the switch to give DC excitation, because when you give DC excitation, then only the motor will continue to run at synchronous speed. Okay, will continue to run at synchronous speed. Are you understand my point? Are you understand my point or not? Okay, so what is the purpose of TPST switch? The TPST switch will be operated, okay, only for to run the motor to continuously to run at synchronous speed. Okay, as well as we are by you giving the DC excitation, this TPST switch will be applicable, because without TPST switch, okay, you can't give the DC supply to your winding arrangement. Okay, to your arrangement. So the TPST switch will be plays a major role. Okay, in your lab, I will show how the what is a TPST switch will be there. The triple pole double through switch. Triple pole double through means you see here. Triple pole 1, 2, 3. Triple pole. Double means the switch will be operated in left side as well as the right side. You see here, which will be operating to control the DC supply as well as which will be operating to control the resistance value also. Okay, so in both the cases we can operate it. Okay, that is the purpose of triple pole double through switch. Okay, triple pole double through switch. I understand this concept. I understand. This is the concept of slip ring induction motor. Okay, slip ring induction motor. And fourth method, the theory, you can see the theory, whatever the concept which I explained, it is there. Okay, the theory which is available. Okay, and fourth method will be a small DC machine. What is going to be a small DC machine? Okay, I will explain the arrangement here, how to do. This is the bed. Okay, bed. So here bolt. Okay, now we are fixing the motor. Okay, this is a synchronous motor. Understood? So here you are giving 3-phase supply. Okay, now this is a shaft. Okay, this is a shaft. Now DC machine, I have to take another motor, that is DC generator. Okay, DC machine means we are taking a DC generator. Okay, or alternator DC generator we can take with the same capacity. This is DC machine, same height, same length. We have to take the shaft of the motor of the DC machine, which will be coupled. Okay, which will be coupled. This point will be coupled. Okay, the meaning of coupling means we have to connect a two machine. The shaft of one machine will be connected with the shaft of another machine. Okay, so if synchronous motor will be running at 1500 rpm means the DC machine should also be running at 1500 rpm. Both should be run at a clockwise direction. That is the concept of coupling. And another point, the coupling effect you already studied in your magnetic circuits. In what is that? Basic electrical or a circuit theory like that. Coupling effect, coupling coefficient K. Okay, K equal to M by square root of L1 L2. Okay, this is coupling coefficient. This M is nothing but magnetic coupling. Okay, the same concept here also we are doing. Okay, coupling effect. And another point here, and why we need this coupling effect. Okay, sometime for testing arrangements we need a DC machine to make synchronous motor to run at synchronous speed. Because for example, if you take a large machines, the 3.3 or 5 kilowatt machines or 5 HP machines, it won't run. Okay, it won't, because sometimes because the windings are perfect, but sometimes the machine it will be run at only 495 rpm. It won't run at 1500. To make that machine to run at 1500, they need again a device to connect. So for that, a cheaper device they will take DC machine. They will take DC machine. This is one of the testing arrangement. Okay, this is one of the testing arrangement, because anyway we are giving the DC supply. Okay, in field winding, okay, inside synchronous machine there will be a field winding will be there. In field winding we are giving the DC excitation. Okay, so to adjust this DC excitation, they are connecting with DC machine. Okay, DC machine. The operation, it is very simple. Okay, very simple. The machine is used as DC motor to rotate at synchronous speed, at asynchronous speed. Then we can say it will be an exciter. Okay, the DC machine which we are coupled with your synchronous motor, that is known as exciter. So for today class, I explained two concepts. One is when you say note down, please note down, when synchronous machine, synchronous motor will be coupled, okay, which will be coupled with induction motor, then the concept is known as Pawnee motors. Okay, this is my first point. When synchronous motor coupled with induction motor is known as Pawnee motor. Second one, when synchronous motor coupled with DC machine. DC machine means a generator. You can say it will be alternator. Generator. Then the concept is known as exciter. Okay, exciter. Please note down, when synchronous motor coupled with DC generator, that is known as exciter. Okay, when the synchronous motor coupled with the induction motor, then it is known as Pawnee motor. Okay, so today class explained four methods to make the synchronous motor to self-start. Okay, what are the methods? The first method will be a Pawnee motor. Second method will be a damper winding. Third method will be a slip ring induction rotor. Fourth method will be a DC machine connected. That is known as exciter. Okay, this one it will be a 10 mark or a 15 mark question. Okay, the last topic, difference between synchronous motor and induction motor. Okay, synchronous motor, induction motor. Please take down. There are 10 points out there. Okay, in synchronous motor, the construction is complicated. But induction motor, the construction is simple. It is simple. Synchronous motor is not self-starting, but induction motor, it is self-starting. Third one, a separate DC source is required for field winding to give rotor to excitation. But here there is no DC. Okay, there is no DC source. Only induced EMF only we are giving. There is no DC supply. We are operating in DC induction motor. Fourth, the speed is always synchronous. Synchronous means NS value irrespective of the load. But here, induction motor, the speed is always less than synchronous speed, because based upon the load, the speed will be reducing. And here, synchronous motor, speed control not possible. Why it is not possible means the speed is automatically, it is constant, it is NS. But here, the speed control is possible, but it is difficult because there is some of the methods are there to control the speed. Sixth one, as the load increases, the load angle, that is nothing but alpha, increases, keeping speed constant as synchronous. But here, the load increases, that speed keeps on decreasing it. Seventh, by changing excitation, the motor power factor can be changed from lagging and leading. Okay, lagging stands for, what is the lagging stands for? It will be called inductive load. Leading stands for capacity load. But here it's always operate at lagging power factor only. Okay. Synchronous motor operates at both lagging and leading, but induction motor is operated at only lagging power factor. Okay. And as well as to control the power factor is not possible in induction motor, but here it is possible. Okay. And another one, here it can be used as synchronous condenser. Okay. Synchronous condenser. What does mean by a synchronous condenser? Anyone knows? Any idea about synchronous condenser? Can you please tell me? Anyone knows about the synchronous condenser? Students? Sarthak? Nishal Dinesh? You have any idea about synchronous condenser?
No, sir.
Okay.
No, sir.
Okay. I will explain the what is synchronous condenser. Okay, synchronous condenser means when when synchronous motor synchronous motor is over excited. Over excited means what is the condition, ma? Over excited. EB back EMF is greater than V phase, terminal voltage V phase. During this time, there will be a leading power factor current. Okay, leading power factor as well as armature current, power factor current. Okay, since we know this is V, it will be IA. Okay, it will be a leading. Okay, it will be leading power factor current. So if the synchronous motor is on no load, okay, now we are not applying any load in the motor. So you in this time the load angle delta, okay, load angle delta, okay, delta is very small. Okay, delta is very small. So because of this delta is very small, then the power factor angle phi is increases. The power factor angle will be increases. How much it is increases to 90 degree, it will be increases. Power factor angle. Okay, power factor angle. Cos phi will be increases to 90 degree. Okay, and then the motor runs with almost zero leading power factor condition. Okay, so during this time, since it will be leading, there will be a normal capacitor. Okay, normal capacitor which will takes this leading power factor current. Okay, leading power factor current. Since the motor is over excited, so the synchronous motor, okay, synchronous motor having having capacitor. Okay, synchronous motor having capacitor. So since the machine is having capacitor, because it is having that over excited means leading power factor. You already know about leading power factor. Leading means it is only applicable to capacitor, lagging means inductor. Okay, so since the capacitor is operating in induction motor, so we are calling as, it will be a synchronous capacitor. Okay, it is synchronous capacitor. The another name of synchronous capacitor is known as synchronous condenser. Okay, okay, since the synchronous motor will be operating capacitor, so we are calling a synchronous capacitor. So the other name of synchronous capacitor is known as synchronous condenser. Understood or not? As well as this synchronous condenser, it is one of the property due to which a synchronous motor is used as a phase advancer. Okay, as well as this method, the synchronous condenser method, where they are using means which will be applicable for a power improvement device, which is applicable in substations. Power improvement device. Okay, to improve the power, they will use this condenser in the substations. Any doubts? Any doubts? Okay, and the last point will be the motor. Synchronous motor is very costly. It requires frequent maintenance. It is very costly. But induction motor, it is very cheap. Maintenance will be free. Okay. Any doubts? Thank you.